problems that we have and we need to solve are just descriptive. They just describe a situation, and we need to translate it. We need to translate it from words into algebra, so numbers and variables. So for example, and then sometimes then we need to, because we can't show it on a diagram like we did on the last one, we'll need to define what each of the variables means. So sometimes we might want to say something like, let x be the smaller number, or let x be the first number. Then we're going to use the description to write an equation. So example 4, 2 less than 2/3 of a number is 40. Find the number. So here we have 2 less than. So we know that 2 less than is subtracting 2. 2/3 is a fraction, which we'd write like this, 2/3. Of always means to multiply of a number. Now we don't know what the number is, so we'll let the number be equal to n. Is always represents equals 40. Find the number. So here we have 2 less than, so we're going to go through. We have 2 less than, so it's going to be, remember, take away 2. So it does not mean that I'm going to, 2 less than does not mean 2 minus, but it means to take away 2 from the number. So 2 less than 2/3 times our number, which is n. So we'd write it that way. 2/3 times n is, there's my equals, 40. And I would set it up that way. I need to solve it. So we could multiply by 3, but it's pretty easy to add 2 to both sides. That will leave us with 2/3 n is equal to 42. Then to finish solving, since I have a fraction, I can multiply by its reciprocal. So 3/2 times 2/3 and 3/2 times 42. These cancel. This leaves me with an n is equal to, so remember we're multiplying a whole number times a fraction. I like to take the 42, divide it by 2, that gives me 21, and then 21 times 3 is 63. So again, you could come to the side and divide if you wanted to, and then multiply it out to get your answer. So n is 63 is our answer. Example 5, I have 2 integers that have a difference of 9. 5 times the smaller is 7 more than 3 times the larger. Find the integers. Well, this time I have 2 integers that I'm talking about, 2 numbers, and so we'll let one of them be the smaller one. So we'll let the smaller one be equal to x, so our smaller number is x. It says 5 times the smaller is 7 more than 3 times the larger. Find the integers. If the difference of our 2 numbers is 9, we know that. So I have another number, so it's going to be, we'll call it our larger number. It's going to be larger, and there's a difference of 9. So in order to get there, if it's larger, that means I'm going to add to it. So I'm going to add the 9 to it. So the small number is x. The large number will be represented by the expression x plus 9. All right, so now we're going to go to the second sentence. I have 5 times the smaller. So we'd write then 5 times the smaller, and the smaller is x. So 5 times x is, remember, is equals 7 more than, so that's 7 plus. So we'll put 7 plus 3 times the larger. And the larger is represented by the expression x plus 9. So I will put that in parentheses because it's going to be 3 times the entire expression. So there I have it. 5 times the smaller is 3 times, 7 more than 3 times the larger. So now I'm ready to solve it. So I'm going to distribute my parentheses, and I will have 5x is equal to 7 plus 3x plus 27. I will simplify this left side. I can combine the 7 and 27. So I'll have 5x is equal to 3x plus 34. Now I will combine my x's, so I'm going to subtract 3x from both sides. And that will leave me with 2x is equal to 34. Finish up by dividing by 2. And I have x is equal to 17. All right, so let's go back and look at what we need. We need to find the integer, so I want both of them. So that means that the smaller one is 17, and the larger one will be x plus 9, which is going to be 17 plus 9, which will be 26. So our numbers are 17 and 26.